So we're going to factor trinomials again, but this is actually pretty much day 3 of notes. And then there's going to be some other things, you know, those little tweaks and everything that come up in these. So what I want you to do right now is I want you to factor number 1 and 2. Well, I want you to factor number 1, pause your screen, go and factor, and then come back and see if you remember, and because you never can get too much practice with this. So you're going to do number 1 right now, go. So hopefully you have it so far like this. We know that we're going to multiply 6 times 7, therefore getting 42. We know that B is 23. We list the factors of 42 in pairs. We have listed those all out. We want the pair that when added gives me 23. We know that's 22 and 21. Now we're going to write it in expanded form. So we have 6x squared plus 2x plus 21x plus 7. I'm going to factor by grouping now. So I'm going to take a 2x out here, and I get 3x plus 1. Take out a 7 here, and I get 3x plus 1. So I get 3x plus 1 and 2x plus 7. Good. Okay, number 2. I want you to pause your screen right now, and I want you to get started on that one. And work number 2. Go ahead, pause your screen, do number 2. So hopefully you took 2 times 2 and got 4. Hopefully you got this far. If you didn't pause your screen already, try it. But you took 2 times 2 and got 4, and put that at the top. B is -5. It goes here. The factors of 4 are 1 and 4, and 2 and 2. Now, the top is positive, but the bottom is negative. So that means my signs are the same, because I have a positive here. They're all negatives. So now I have a -1 and a -4. So I have 2y squared minus 1y minus 4y plus 2. And we're going to factor by grouping. So take a y out here. I get 2y minus 1. Oh, third term is negative. Factor out a -2, and I get 2y minus 1. So I get 2y minus 1 times y minus 2. Good. Okay. Do number 3. Go. Okay, so you took 1 times 9. 9 goes up at the top of the x. B is 6, so it goes at the bottom. So I'm going to find the factors of 9, 1 and 9, 3 and 3, which pair when added gives me 6, 3 and 3. Write it in an expanded form. X squared plus 3x plus 3x plus 9. Factor by grouping. Remember, you can pause your screen at any time and just try this and see if you're remembering it, and then come back in. Now what's in the parentheses is the same, so I get x plus 3 and x plus 3. Whoa, got the same thing. If I get the same thing in the parentheses, if I get the exact same thing, then I need to write it as x plus 3 quantity squared. If the binomials are the same, make sure to write it as quantity squared. Okay, so if I get the same thing in the parentheses, I'm going to write it as quantity squared. Sorry about that. Okay, so we're going to write it as quantity squared if it's exactly the same. Try number 4, go. So in this one we get big numbers. We don't want to actually do that, do we? So let's pick a number that we think might go into 225. Well, we know 5 goes in. How many times does 5 go in? Oh, wait. And we have a positive number here. We have a negative here, so everything's negative. Do you see what I'm doing? If this is positive, my signs are the same. They're the same as B. So they're both going to be negative. 225 divided by 5. Negative 45 when added is 50. Okay, nope, that's not going to happen. Let's get them to be closer together. So let's go up. Does 10 go in? No. Does 15 go in? Oh, yeah, because look, 15 squared is 225. When I add those two together, do I get negative 30? Yeah, 225 is a perfect square. It's 15 squared. So we get a negative 15 and a negative 15. So I have 25x squared minus 15x plus 9. Factor by grouping. I'm going to take a 5 out here. I'm going to take a 5x out. Thank you. 5x. Now here I'm going to take out a negative 3. Wow, not paying attention there. I was not. Okay, 5x minus 3 because I took out a negative. So look at that. I get 5x minus 3 and 5x minus 3. Same thing in the binomials are the same, so I write it as 5x minus 3 quantity squared. Now you might remember this is a special case. This is what is called a perfect square trinomial. And perfect square trinomials, remember, were special cases and we had shortcuts. We had shortcuts in order to multiply, well, there's shortcuts in order to factor. I'll show you that on the next page. Let's look at this next one. So special cases, we're talking about special cases today. So this is day 3, but pretty much what it's talking about is special cases. So it means we're talking about a perfect square trinomial. And we can identify those because, well, we'll talk about it on the next page. The other special case we have is if we have 2 terms, okay? If I have 2 terms, what's my middle term? Think about it. What's my middle term? If it's not there, my middle term would be 0x or just 0. So when we go to factor this, we still multiply a times c, but we don't have a b. So our b is 0. And here I'm going to get a negative 36. Looking at that, negative 36, okay, that's going to be a big clue. And you're going to see this in just a second, what's going to happen here. I have to add them to get 0. So if I add 2 numbers together to get 0, don't they have to be the same numbers, just opposites? So I could list the factors of 36, but I already know what's going to happen because it's going to come out to be a 0. Okay, my signs have to be different. One is positive and one is negative. Which one is positive and negative? It won't matter. Whoops, that's 3 and 12. Because it has to be 6 and 6. One is positive and one is negative because you have to add to get 0. So one is positive and one is negative. Okay, so when we write this out, it becomes 4x squared plus 6x minus 6x minus 9. Okay, I'm going to pause for just a second. So what I noticed is that I have to add to get 0. If I add and I get 0, my numbers have to be opposites. One is positive and one is negative. So which one do I make negative? It doesn't matter. Does not matter. Just one of them has to be negative. So now factor by grouping, I'm going to take a 2x out. Third term is negative, so I'm going to take out a negative 3 here. So notice what I get. It's not the same in the parentheses. The binomials are the opposite. Same terms, opposite sign. That is my answer. Remember, these are called the difference of squares. So, just to let you know that. Okay, so knowing that, let's look at this one, because look at these big numbers we're going to get. We still make our x, but we have a middle term of 0, so that means we're going to find 2 numbers that are the same. Let's go ahead and do that. That's a horrible one. 49, whoops, times 36 gives me 1764. Yeah, want to list those factors? I don't think so. But what we know is the number has to be the same, so think about that. If the number has to be the same, this has to be a perfect square. This has to be a perfect square. So take the square root of that number, and take the square root of that answer, and I get 42. That means I'm going to have a positive 42 and a negative 42. Okay, I'm going to go through that again. If I add and I get 0, that means that these have to be the same number but opposite sign. Well, if that is true, that means this has to be a perfect square. Because what number? You have to be able to take a number times a number to get that. You get a negative. Whoops. Yeah, I can mark it over there. So I know my signs are different. Okay, so now we're going to have 49x squared plus 42x minus 42x minus 36. Factor by grouping. Third term is negative. So I get 7x plus 6, 7x minus 6. Okay, so notice AC method works no matter what. Let's look on back. I'm going to talk to you through the shortcuts. Difference of squares. Now this shortcut I use all the time. Okay, I use this one all the time. Don't use the AC method on this one. I use a shortcut. So first you have to be able to identify 2 terms. That is crucial. And both have to be perfect squares. And there needs to be a minus sign, or at least one term has to be negative. So we're going to do this example, go through our shortcut. So here we go. Really, if I've identified, yep, perfect squares, I have a minus sign. Yay, I can use a shortcut. 2 terms. Make 2 sets of parentheses. Write 2 different signs. Take the square root of the first one. Square root of 16 is 4. Square root of x squared is x. Square root of 81 is 9 and 9. I'm done. Okay, I took the square root of each and put it in respective places. Okay, let's do another one. Do I have 2 terms? Yes. Oh, duh. 2 terms. Are they both perfect squares? Yes. So, if they're both perfect squares, do I have a minus? Yes. So I make 2 sets of parentheses. I have 2 different signs. So if you notice all the 2's, 2 terms, 2 sets of parentheses, 2 different signs, takes a square root. Try this one. You try number 2. Don't rewrite it. Are they both perfect squares? Yes. Do I have a minus sign? Yes. So I have 2 sets of parentheses, 2 different signs. And you can go minus plus. It honestly does not matter. I just tend to go plus minus. Take the square root of 64, square root of 9, square root of x squared, and I'm done. So that shortcut is really handy. I love that one. Okay, here we go. Both perfect squares? Yes, they are. Whoa, I don't have a minus sign. This one is not factorable. This one is said to be prime. Okay, I cannot factor that one. 2 terms, that with a plus sign is going to be prime, unless there's a greatest common factor. You always look for the greatest common factor. We'll talk about that tomorrow. Perfect square trinomial. I don't use this one as much, but you need to know about it. The reason it's a pain, it's not a pain to factor. You can see that. The pain is identifying it. You have to have 3 terms. It's a trinomial. Hello, people. It's a trinomial. First and last terms have to be perfect squares. Here we go. 25 and 49. Are those perfect squares? Yes, they are. X squared, perfect squared. Okay, now this is what you have to pay attention to. The middle term is the square root of the first, 5x, times the square root of the last, 7, times 2. So I have to take the square root of the first, square root of the last, times 2. That's 35 times 2. That's 70x. So this is a perfect square trinomial. Oh, and this sign always has to be plus. Okay? Now to factor is really easy. Identifying is the hard part on this one. So to factor, make 1 set of parentheses with an exponent of 2. Take the square root of the first. Square root of 25 is 5x. And the last term. So take the square root of the first and the last term and put in respective places. The sign will be the same sign as the first one in here. So the sign will be the same as the first one here. So if that's a minus, this is a minus. If that's a plus, this is a plus. Really quick to factor, you just have to pay attention. Is it a perfect square trinomial? So let's look. Oh, that's supposed to be x squared. Here we go. Identify 3 terms. Check. First and last term have to be perfect squares. Check. Now, is the middle term. I have to take the square root of the first times the square root of the last times 2. Gives me 8x. It's a perfect square trinomial. So now I get to factor. I'm going to make 1 set of parentheses. Exponent of 2. Take the square root of the first term. Square root of the last term. My sign is whatever I have there. I'm done. Now, I can make an x. And so I can also factor this one. I could have made an x. So this is a shortcut. I put 1 times 16. That's 16. This is negative 8. Factors of 16. My signs are the same. They're both negative. Which pair when added gives me negative 8. Write it out, expanded form. Factor by grouping. Third term is negative. So I get x minus 4 times x minus 4. That's x minus 4 quantity squared. Same answer. Okay? So I can still do it this way. Just to let you know that. Okay. Number 2. First, I want you to pause and see if this is a perfect square trinomial. So the first thing you have to do is see if this is a perfect square trinomial. Is it? I have 3 terms. Yes. Is the first term a perfect square? Yep. Last term a perfect square? Yep. If I take the square root of this one times the square root of this one times 2, do I get 12x? Yes. This one is factorable. So that's the hard part, identifying I can do it. Then I make one set of parentheses with the quantity squared. Take the square root of the first term, square root of the last term, and whatever this sign is. Okay? You might be going, well, where did the middle term go? If you multiply this out, you would get that middle term. Okay, so those are the shortcuts. Just to let you know, this one I use exclusively. This is all I do. This one, sometimes it takes me longer to figure out if I can do the shortcut. So sometimes I just go through and do this way. It just depends on where I'm at and the mood I'm in, okay? So let's look at homework. Now, on these, it's pretty much going to tell you if it has 3 terms, it's a perfect square trinomial. It has 2 terms, okay? You can use those shortcuts. So we're just going to have you do one column of these. Which one did I decide? I think it was. Check with your teachers. You're going to do 1 or 2 of these columns. I don't remember which one, so your teacher will let you know that. And then you're also going to do this one. You have plenty of time, and this is good practice. This will help you get ready for the test. Here, all you're going to do is the common factor. You're just going to take out the greatest common factor and stop. So you're going to factor out the greatest common factor and stop. Here, you're going to factor these. There is no greatest common factor. And look, you get to do everything. 3 terms, 2 terms, 2 terms, 4 terms. So you have everything in there. There might even be a perfect square trinomial in there. I don't know. Okay? So, great. Check with your teacher as to what the assignment is. If you have any questions, you know where to find us.